Electron configuration. It can be pretty difficult at first, but once you kind of understand the basic rules, it's a piece of cake. Let's just kind of dive right into it. Let's just talk about some basic things at first, though. First of all, there's three types of main orbitals. There's a fourth, but we'll get to that eventually. There's the s orbital, the p orbital, and the d orbital. So some main things about the s orbital is that it contains at max 2 electrons. It can contain less, so it can have 1 or it will have 2. It's located on the first two groups. First two groups contain the s orbital. The p orbital contains at max 6 electrons, so it can have 1, it can have 1, 2, 3, 4, 5, and 6. And it's located within it's located all the way on the right, so on those last few groups there. And the d orbital, this contains at max 10 electrons, and it's located in the middle of the periodic table. Okay, so that's just a basic overview of the main things that you kind of need to know before we really dive into writing the electron configurations. Okay, so we know about the s orbital, we know about the p orbital, and we know about the d orbital. So the best way to kind of attack it is realizing how many electrons are in the atom or the element's atom that you're trying to represent. So let's kind of just go through that part first, because I think that's really important to understand before we can really write them too. So let's just pick a random element here. Let's do boron first. So boron, its atomic number is 5. What does that tell us? So its atomic number tells us how many protons there are. So that means we have 5 protons. Well, the goal of an atom is to be stable. So if it has 5 protons, it must have 5 electrons. Okay? So that's how we figure out the number of electrons for each element. It equals the atomic number, right? So if we were to pick something, a little bit harder here, say we were to pick aluminum, right? Aluminum's atomic number is 13, which means that it has 13 protons. So as a result, it will have 13 electrons. Okay, pretty simple. This next part that we got to really dive into contains that whole talking about the total electrons. So I think the best method to really do it is just show the progression of it. So it all starts out with the 1s2. After 1s2, it goes to 2s2. Then it goes to 2p6. Then it goes to 3s2. Then it goes to 3p6. Whole goal here is just, totaling up that number of electrons and showing the different orbitals that it's occupying. So far, say so far we've titled up, let's see how many electrons. 4. 4 plus 8 is 12. 12 plus 6 is 18. So this would represent 18 electrons. So let's look back at our periodic table here. Which one has 18 electrons? Oh, argon. So what we just wrote out was the electron configuration for argon. That's what it is. So this is what the electron configuration would look like. You see how I did that though? Our whole goal is just getting to that 18, getting to that number of electrons. So we're just going to keep adding one orbital on top of the next just to get that 18 electron amount. Pretty simple, right? So let's go to our next one here. Let's say if I wanted to do just a simple one. Let's say if I wanted to just do helium. I really think this is the best way to kind of teach this topic. So it has a atomic number of 2. Atomic number of 2 means it has 2 protons. It also means it has 2 electrons. So we start out the same way as last time. Our goal is to get to 2 electrons. So our goal is to get all the all the exponent numbers to add up to 2? Well, we know we start from left to right. So we know we could go 1 hydrogen, which would be 1s1, since we know all the s's are on this side and p's are on this side. So it'll be 1s1, and the 1 stands for our energy level, and it's first period 2. We know we need 2, so we know the s level can maintain at max 2, so it'd be 1s2. That's how we write the electron configuration of helium. Let's go to our next one. Let's say if we wanted to do the electron configuration of neon. Neon has an electron configuration of 10. So how we go is we go 1s2. Okay, that's 2 electrons. We need to get to 10, so we need 8 more. Let's go to 2s2. That's 4. We still need 6 more. Okay, now we have to go to 2p. And how many do we need in that p orbital? We have 4, and we need 10 total. So 10 minus 4 is 6. And the p orbital can hold at max 6. So this here would then be our electron configuration of neon. Making a little bit more sense? So we always start with that 1s2. Then we go to the 2s2. Then the 2p6. And the p's can vary, and so can the 1s's, to adjust to that number of electrons. But you can't write, say, 1s1 and then 2p5. You always have to complete each orbital and go to the next one. So say for that neon one, so let's write it back again, for 10, you always have to complete each energy level. Here, let me just write that over again. So I always have to complete the 1s2 energy level. I have to then complete that 2s2 energy level. Then I have to go to the 2p6. I can't do 1s1, 2s1, 2p7. Well, they all add up, 2p8. They all add up to 10, but we're not completing each energy level. In this one, we're even going way over. So that's why it's best to just kind of keep that systematic of, filling those S's and filling the P's and kind of looking. After a while, it sort of becomes second nature of doing it. Let's do a little bit harder one here. So let's do phosphorus. So that's 15. I'm going to give you a second or two to try it. So just kind of think it over in your head of how you would write it. Okay? So we would go 1s, let's see. Do we complete the first energy level? Yep. 1s2. Do we complete the second energy level? Do we complete that second energy level there? So we have the 2s2 that's completed, right? Then we have our 2p6 that's completed. Now we're down to our third energy level, 3s2. Well, that so far has given us 12 electrons total. We still need 3 more. So now we need to go 3p, and how many did we say? 3 more. This concludes this video. I'm going to be making a part 2, just doing more examples, just more practice. But I'm hoping this will give you a good start of understanding how to write electron configurations. If it doesn't make sense, maybe the next video will give you a better understanding. But really, it's just all about practice, and you got to just do it. Thank you. Have a great day.